All right, let's talk about something that pretty much everyone who's ever touched software knows all too well. It's that feeling, right? You open up a project and you're just hit with this wall of code. It's complex, it's ancient, there's zero documentation. It doesn't matter if you're a junior dev or a senior architect, it's a universal problem. How do you even begin to understand a system when the people who wrote it are long gone?
And look, this isn't just some minor inconvenience. Researchers have a name for this. They call modernizing these old systems a wicked problem. And for good reason. We're talking about the code that runs our banks, our airlines, our entire infrastructure. It's absolutely critical, but it's also so fragile that trying to change anything feels like playing a game of Jenga.
So what's the move? How do you tackle a code base that's basically a giant, inscrutable puzzle? Well, that's what we're going to dive into today. We're going to unpack the modernizer's playbook and look at everything from automated tools to intense human-led strategies, and even the new frontier of AI. Okay, first things first. Before we can even talk about solutions, we have to get our heads around the sheer scale of the challenge. When you're staring down a mountain of legacy code, what is it you're actually trying to do?
The official term for this is software architecture recovery, and what that really means is you're creating the documentation that should have existed in the first place. Honestly, the best way to think about it is like digital archaeology. It's like someone gives you the keys to an enormous, complicated building, but tells you there are no blueprints, and your job is to create them, from scratch, just by carefully inspecting every single room, wire, and pipe.
So where do you even start with a task that huge? Well, you start by reaching into your toolbox. Specifically, you grab the automated tools that are designed to scan and analyze code at a massive scale. This is always your first line of defense.
And that toolbox has a whole range of specialized instruments. For just keeping your day-to-day code clean, you've got quality gates like SonarQube, which kind of acts like a bouncer at a club. For security, you've got things like SemGrep, which is like a custom metal detector you can program to find very specific problems. And for the really old, gnarly stuff, there are tools like Swim that are built to go in and excavate business rules that have been buried for decades.
These tools are frankly a lifesaver. They give you an incredible head start. They can map out all the dependencies, flag potential bugs, and just give you that high-level bird's-eye view of the landscape in a tiny fraction of the time it would take a person. But there's always a but, isn't there? What happens when the system is so old, so complex, that the tools just throw their hands up in the air? What do you do when you're facing a mission-critical system that is, for all intents and purposes, a complete black box?
This is where you bring in the heavy artillery. We're moving past the automated scans now and into a deep, methodical, and very human-led investigation.
Now, I gotta be really clear here. This is the last resort. This kind of approach is expensive and it's incredibly labor-intensive. You only do this when the system is so critical it cannot fail, and every other method you've tried just hasn't been enough. So how does it work? The process is actually borrowed from the social sciences, and it's called grounded theory. It's a three-stage process. First, open coding. Here, an analyst basically becomes a detective, meticulously going through the code and tagging every piece of evidence with a concept or a code. Then comes selective coding. Now they take all those tags and start clustering them together, looking for patterns. Imagine a detective's evidence board with photos and strings connecting them. It's like that. And finally, theoretical coding. This is where they model all those relationships to build a single, unified theory of how the entire system works.
You can really see the flow here. You start at the bottom with all these individual pieces of raw data, the codes. Then you group them into categories, which in turn start to reveal these higher-level patterns. And from those patterns, a single, clear theory of the software's architecture finally emerges at the top. It's a methodical way to literally build clarity out of chaos.
Okay, let's pivot now to the newest tool in the kit, the one that everybody is talking about, artificial intelligence, specifically large language models. Could this be the silver bullet we've all been hoping for?
Well, the early research is pretty fascinating. Take a look at this chart. It's from a study on readability. When an LLM was asked to generate comments for code, human experts consistently rated the AI's comments as more readable than the ones written by the original developers. That sounds like a clear win for AI, right?
Well, not so fast, because when those exact same experts were asked to rate the usefulness of the comments, the story completely flips. As you can see, the human-written comments, even if they were a little less polished, were rated as way more useful for actually understanding the code. The big takeaway? The AI is a good writer, but it's not yet a good engineer.
And this gets right to the heart of the challenge with AI in this space.
Right now, the automated metrics we use to judge the quality of an AI's output, the way machines grade themselves, they just don't line up with what human experts think is actually good or useful. To put it simply, we can't trust the machine to grade its own homework just yet.
So, we've looked at automated tools, deep human analysis, and the double-edged sword that is AI. How do you pull all of this together into a strategy that actually works? Here it is, the modernizer's playbook. First thing to accept, there is no silver bullet, period. You start with automated tools to get a quick, broad analysis. For those supercritical black box systems, you invest in deep human-led methods like grounded theory. And you treat AI as a powerful co-pilot, let it speed things up, but you always need a human expert in the driver's seat reviewing its work. The right approach is always a smart mix of all these techniques.
Ultimately, it's worth remembering what the computer scientist Peter Knorr once said: programming is theory building. And he was so right. Your code base isn't just a bunch of files, it is the living, breathing theory of how your business actually operates. And so the final question is, are you really ready to understand it?